Hello, and welcome to Mkoya Analytics. My name is Saruddin, and I'll be your tutor in this class. In this tutorial, I will introduce you to the concept of machine learning, which is a subfield of artificial intelligence that focuses on the capability of machines to imitate intelligent human behavior. These two concepts might sound complicated, yet they are actually very simple to understand, so let's get started. As humans, we consume a lot of information, but often don't understand these data points. Our brain automatically saves this information somewhere and recalls it when we need to make future decisions. When we see a picture of an animal, for example, we instantly know what the animal is based on our prior experience. From the time we were born, we started developing the ability to learn and get better at our activities through experience. We learn through listening, experimenting with sounds, moving our bodies, reaching for objects, tasting foods, and exploring our environments. Our brains go through amazing changes during the first few years of our lives. This learning path continues until we reach old age and our brains start to unlearn. In simple terms, we continue learning from everything we experience and use those learning points to make future decisions, constructing our knowledge through experiences. A typical example of learning to make daily decisions based on past experiences is determining how much time it takes someone to get to their workplace from home every morning. This depends on several factors, which includes distance from home to work, weather conditions, route he takes, the day of the week, traffic conditions, etc. For example, suppose Mr. Med wants to figure out how long it takes him to get to work from his house every morning. The distance from his house to his workplace using the mere route is 10 kilometers, and on Monday it takes him 6 minutes to get to work. On Tuesday, however, it rained and he had to drive slowly and reached his office in 10 minutes. So bringing rain into the picture increased arrival time by 4 minutes. On Wednesday, it did not rain, but there was too much traffic and he reached his office in 15 minutes. On Thursday, to avoid traffic, he changed route and arrived in 5 minutes, which suggests that this route is faster than the usual route. On Friday, he used the same fast route, but there were a lot of road users, many of whom were traveling for the weekend, and he arrived office in 30 minutes. His brain stores all this information somewhere and recalls it when he needs to make a similar decision. For example, if the following Monday it rains, he will recall from this stored information that it will take him approximately 10 minutes to get to work, everything else equal. However, something new could be happening on that very day, which he had not experienced before, such as a minor road mishap, which could make his arrival time longer. In reality, we can never anticipate all possible things that could happen, and therefore, we could only predict to a certain extent what will happen in the future. There's always a level of uncertainty in whatever we plan to do, and in statistics, we call this an irreducible error. Therefore, just having to think of all the possible things that could happen on the way to work and predicting a possible arrival time can take up some of our valuable time and energy, and quite often we end up making wrong decisions. Fortunately, we have a set of superheroes who have devised ways of training computers to use available information about our past experiences and do the thinking for us, thereby saving our time and energy. For example, we can give a computer a picture of a cat and a dog and tell it which one is which, and allow the computer to seek statistical patterns within the pictures that will enable it to recognize these two animals in the future. The more pictures of different species of cats and dogs the computer sees, the better it becomes in recognizing these two animals. From our earlier example, we can actually feed this data into a computer model and make the computer train itself based on the experiences we had. So in the future, when we wake up on a Friday morning and it's raining, our computer model should be able to give us a predicted time of arriving at work. This process whereby we teach computers to become artificially intelligent, learn based on past experiences, and perform complex tasks in a way that is like how humans solve problems is called machine learning. Machine learning is a subfield of artificial intelligence which brings together statistics and computer sciences to enable computers to imitate intelligent human behavior of learning from experiences by independently identifying patterns in data using various machine learning models and algorithms. In fact, for this example, we already have computers doing this kind of thinking for us in the way of GPS. Majority of drivers now use GPS systems to determine the best route to take to their destinations. The question is, how do computers make these predictions? It actually starts with gathering data and observations and then dividing the data into a training set, which is the information that the machine learning model will be trained with, and a testing set, which is used to validate the accuracy of the model. The more data we have, the better it is for the model to make more accurate predictions. Based on the data we gathered, we choose a machine learning model to use, feed in the data, and ask the model to train itself to find patterns or make predictions. Then we use the testing data to test how accurate the machine learning model is when it is shown new data. The result is a model that can be used in the future with different sets of data. Model selection is analogous to different ways in which the human brain perceives information. Some information is better understood visually by the human brain than through audio-only channels, while other information, like understanding machine learning, could be very complex that the human brain needs a good tutorial that breaks down the information into simpler terms. Consequently, the choice of machine learning model depends on how well it explains the relationships in the data. The four basic approaches to machine learning are supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. We use these approaches to explain what happened, which we call descriptive analysis, predict what will happen, which we call predictive analysis, or make suggestions about which action to take, which we call prescriptive analysis. My tutorials will focus on supervised and unsupervised learning models and provide typical examples of each. Supervised machine learning models are the most common type of statistical models and are used to predict an outcome. In our previous example, we used several variables to predict arrival time, which is an outcome, by training the model on past data that shows the combination of the variables that result in the outcome. Unsupervised learning is a machine learning technique used to identify patterns, that is, similarities and differences, in unclassified and unlabeled data sets, meaning we give the computer only the input data and no corresponding output data and let the computer learn by observing the data and finding patterns on its own, without any human guidance or supervision. An example is using machine learning for customer segmentation. Here, we are not looking for an outcome like arrival time, but rather a group to which an observation falls. Different companies have different use cases for machine learning, and figuring out what problem to solve with machine learning is one of the hardest tasks of many companies, because many companies still don't understand the concept. So let's look at some simple use cases. Facebook, Twitter, Instagram, YouTube, and Netflix have a machine learning algorithm running at the background that learns about the preferences of users and recommends similar feeds, posts, and videos based on past experiences of what users like. In that way, the model screens out most of the unimportant information and gives users only information that is of interest to them. Banks use computers to analyze customer spending patterns or find out where customers normally shop to identify potentially fraudulent debit or credit card transactions. Also, a lot of companies are now deploying online chatbots to offer customer services and interact with the machine. The computer learns from records of past conversations to come up with appropriate responses. In the medical field, machines have been trained to automatically detect pneumonia from X-ray images. Apple devices learn to understand natural language as spoken by humans and respond to it through a digital assistant called Siri. And we also have Alexa for Amazon. Additionally, companies use sentimental analysis to analyze customer reviews, social media posts, and other content to track changes in attitude towards the company's products or services. So the question is, how do we know if machine learning models are doing what they are supposed to do? And how do we determine the accuracy of the models? When a model makes a prediction on a testing dataset, we could objectively evaluate if it has given a correct answer or not because we have the correct labels of the inputs. Business leaders tend to struggle with understanding where machine learning can add value to their companies and consequently deciding how much resources to allocate to it. Models that work for one company might not work for another company, and therefore machine learning models should never be treated as black boxes, even when a model fits a company's needs. This is because sometimes machines could fail to perform certain tasks accurately, even those that could be easily performed by humans. An example is a computer identifying a picture of a dog as a cat. Therefore, companies require experts who can find appropriate machine learning use cases that work for them and can be clear about what the machine learning models are doing and how they make predictions. Even though machine learning models can perform very complex predictions that human beings cannot and are sometimes way faster than human beings, models cannot be depended upon for 100% prediction accuracy. However, even the human brain does not always make predictions that are 100% accurate. The idea is to achieve a reasonable level of accuracy based on the use case of a given machine learning model. And this brings us to the end of this video segment. In the next set of videos, I will explain how the most common machine learning models work across different industries to give us predictions that are reasonably accurate. These include linear regression, logistic regression, linear discriminant analysis, quadratic discriminant analysis, naive Bayes classification, regression trees, classification trees, random forests, XGBoost, support vector machines, and natural language processing, among others. I know these names sound scary, but be not afraid. I will guide you through the workings of each of these models so that you can also become a superhero. If you have in any way understood machine learning from this video, please post a comment, like, and subscribe to my channel, and follow me through this amazing superhero journey. See you in the next video.